Assalamualaikum and hi everyone. Welcome to our video presentation for MAT 183 Calculus 1 Assessment 2. We are Group 7 from class CDCS 110-2A and today we'll be solving and explaining all 4 questions based on the concept of differentiation and its application. Our team members are Nick Alisha, Nukarin Sahani and Nur Nadira. Let's begin our journey.
As for the introduction for our topics, which is differentiation and the answer to question 1. Differentiation is all about finding the slope of a curve on a specific point. It is mainly used to determine the instantaneous rate of change of a function. That is, derivative of fx with respect to x is the function of f prime x, defined as f prime x equals to limit h of approaching to 0, fx plus h minus function x over h. Next, we will go through the techniques of differentiation. First off, we will start with derivative of constant, linear, and power function. As for constant, dy over dx of it will be 0. For linear, say that we have ax plus b, then the derivative would be just a. For power function, say that we have x to the power of n, then the derivative would be nx to the power of n minus 1. Next, we have product rule. How to apply product rule is by using this formula, which is dy over dx equals to vu prime plus uv prime. Next, quotient rule. The formula for quotient rule is dy over dx equals to vu prime minus uv prime over v squared. Lastly, we have the chain rule. How to apply it is by using the dy over dx formula, which is dy over du minus du over dx. And lastly, we have the derivative of trigonometric, logarithm, and exponential. You can read on this table over here. Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Nadira and I'll be solving question 2 of this group assignment project. So, we will move on to question A, 5x squared cotangent x plus 6. So, as we can see here, this question involves multiplication. When it involves multiplication, the rules that we need to apply is the product rule. Generally, when we need to use product rule, we will sort this question into 2 variables, which is u and v. So, generally, the first one will be u and the second one will be v. The next thing we need to do when applying product rule is to derive the question. So, as you can see, I have it here. We will take this question out. So, u is equal to 5x square. And then we have to derive this question to get u prime. So, we will get 10x. How do we get 10x? It is by moving this power to the front and multiply 2 by 5. And then this power, we will be subtracting it by 1 and we will get 10x. We will do the same thing on this one, except that we will use derivative of trigonometry. So, the v is cotangent x plus 6. When we derive it to become v prime, we will get negative cosecant squared x plus 6. And then, the next thing we have to do is just substituting the derivation into the formula, which is dy dx equals to vu prime plus uv prime. So, by order, the v is cotangent x plus 6, u prime equals to 10x over here, plus 5x square, the u, and the v prime, which is negative cosecant squared x plus 6. And then we just have to expand it all and we will get the answer 10x cotangent x plus 6 minus 5x square cosecant squared x plus 6. That is all for question A. Next, we will move on to question 2b. Question 2b is y equals to 4x minus 3 over cos x. So, since this question involves fraction, we will be using quotient rule. Similar to product rule just now, we will sort it out into u and v. So, the numerator will be u and the denominator will be v. So, the u is 4x minus 3. To get u prime, we have to derive it. So, 4x, we will get 4, and negative 3, using derivative of constant, we will get 0. So, u prime is equals to 4. And then for v, we have cos x. So, using the derivative of trigonometric, we will derive this into v prime, and we will get negative sin x. So, just like product rule just now, we have to substitute this into the formula, which is dy over dx equals to vu prime minus uv prime over v squared. And we will get cos x multiplied with 4 minus negative sin x multiplied with 4x minus 3 over cos x to the power of 2. And we will get 4 cos x plus 4x minus 3 over sin x to the power of cos squared x. And alternative answer to this will be if you expand this part, and we will get 4 cos x plus 4 sin x minus 3 sin x to the power of cos squared x. And that is all for question 2.
Hi, Assalamualaikum. My name is Nia Asha Shaira and today I will be solving for question 3. Now let's take a look. Given y ln 3x minus e power of 6x plus 3 minus tangent of 5y equal to 6. Now the question says find dy dx using implicit differentiation. And when you take a look at this question, you have to divide it into parts, which is part A, part B, part C, and then part D. And then first we have to derive for each part, and then we start with part A, which is A equal to y ln 3x, and then we are going to use product rule, which is this is the u and this is the v, and then it will be u equal to y, this is, and then it will be u prime equal to dy dx, and then we have ln 3x, and then we derive it will be v prime equal to 1 over 3x multiplied with 3, and then this is the formula of the product rule, and then we're just going to combine it and then multiply, which is y multiplied with 1 over x plus ln 3x multiplied with dy dx, and then you expand it, and then it will be dy dx, dy over dx ln 3x plus y over x, and then that is it for part A. And then we move on to part B. For part B, we are going to use a derivative of exponential, and then it will be b prime equal to e power of 6x plus 3, and then multiply with 6, and then it will be 6e power of 6x plus 3, and then that is it for part B. And then we move on to part C, which is tangent 5y, and then we label it as 1 and 2, and then we derive it, and then we expand it, and then it will be 5 second square 5y multiplied with dy dx, and that is it for part C. And then we move on for part D, which is 6, we just derive it, and then it will be d prime or equal to 0. After we derive all of the parts, and then we combine them, a prime minus b prime minus c prime equal to d prime, and this is a prime, b prime, c prime, and then d prime, and then after that we have to sort the dy dx to the left, and then the non dy dx to the right, and then it will get this equation. We take the ln 3x and minus 5 second square 5y divide with this equation, and then last for the answer supposed to be, it will be dy over dx equal to 6e power of 6x plus 3 minus y over x divide with ln 3x minus 5 second square 5y, and that is it for question 3. Assalamualaikum and thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Khairul Nisahani binti Khairuddin, and I will explain about question number 4. Question for number 4 is use linear approximation to estimate the value of square root of 5 1023.99 minus 3 over square root of 1023.99 correct to 3 decimal places. So firstly, we should find the needed information for the question, which is the given value. We should take the 1023.99 while the initial value we should take that close to the given value. And next we find the delta x, where we subtract the given value with initial value, and then we got negative 0.01. Next step is we find the function where we change the given value with x, and then we got x to the power of 1 over 5 minus 3x to the power of negative 1 over 2. Next, we find the f prime of x, where we differentiate the first expression that we find from the function. Then after we differentiate the expression, we got 1 over 5x to the power of 4 over 5 plus 3 over 2x to the power of 3 over 2. And then this is the listing that you can do to make sure that you don't substitute the wrong value, where you can write down the formula, and then after that we substitute the value, the information that we find just now to the expression, where we substitute the initial value in the function, and then we plus with f prime of x, and then we multiply with negative 0.01, which is the delta x, and then we solve it one by one according to the bracket, and then we supposedly got the answer for this question, which is 3.906, and that's it. Thank you.
In conclusion, we have explored the concept of differentiation, its technique, and several types of problem, including explicit, implicit, and linear approximation.
We recommend regular practice and collaboration to understand calculus better, especially real-life applications like rate of change and approximation.
Remember to review all rules, show all steps clearly, and understand when to apply each technique.
Thank you so much for watching, and we hope you enjoy learning with us. Bye-bye!